Hi, in this tutorial I will show you how to use rotate about axis node in material editor. So I will show you how to make it local space, how to fix normals and shadow issue, when should we use the cheap version, when should we use the rotator from the blueprint, and how to optimize it. So let's begin. Okay, so here I have my mesh and also empty material. Let's add it on the material slot and let's start work with that. So we're gonna work with world position offset node, output. This is output for vertices movement. So let's add rotate about axis, the default one, plug it here, and now we need 4 inputs. So position is gonna be world position. For pivot point, it's gonna be object point. And it's very important where is your pivot on your object. So in my case, it's in the middle. So it's gonna rotate about this around this point, so around the middle. Then we need a value of our rotation. So we can add, for example, time and multiply it by speed. So S plus left click. Now I have my parameter. Let's call it speed. Plug it here. The value of, for example, it can be like this. Let's plug it here. And then we need normalized rotation axis. So let's add vector 3. Here you have those axes, so you can look which one you like. So for example, I will go with Z, so Z1. And it's very important, it should be a normalized value. If you have 0, 0, 1, it is normalized, but if you go with 1, 0, 1, it will no longer be, so always plug normalized node after that. Now if we apply it, it should start rotate. And we can change the speed of it. Nice. Okay, the next thing that you may notice is that right now it's rotating around the Z. If we rotate our object, it still rotates about around world Z, not local Z. But maybe you want to always rotate as your local Z. So to fix it, it's very easy. Basically, after our vector, we need to add transform vector. We want to transform it from local space because we want to rotate it around local Z to world space. Apply it. Now it's gonna always rotate around the local Z. Okay, so now it's a great moment to talk about rotate about axis chip. So let's see the difference. Let's add the node. Rotate about axis chip. And as you can see, it has only 3 inputs. So world position, pivot point, and rotation amount. The missing one is normalized rotation axis. That's because it cannot use in between angles and it cannot be in local space. It's gonna use world space, so we're gonna plug the Z1. And as you can see, let's reset the rotation. As you can see, no matter how I rotate the object, it will still use the world Z axis to rotate. And also the difference is that that one use less instruction. So here I have 215, and with that node, I have 227. So if you need more complex rotation, use the default one. But if you have very simple rotation, maybe Z-axis only, world Z-axis only, you can use the cheap one. Now, if you pay attention, you can notice that sometimes the shadows are very dark. That's because of bad normals. So we are rotating the geometry, but we are not rotating the normals. So to fix it, we have special node for that. So it's called fix rotate about axis normals. And now we need to plug some inputs. The first one is rotation axis, that's our normalized axis. Rotation angle is our time. And for normal pivots, just put 0. So press 1 on the keyboard and left mouse click and then just plug 0 here. Then we are using the tangent space vertex normal and plug it into normal. Apply, and it's gonna fix the normal issue. Next issue is that we have something wrong with the shadows. So it's like clipping them sometimes. To fix it, it's very easy. We're gonna go to details, search for word, and now we have this max word position offset displacement. So because we have quite big offset in our vertices, we just need to boost some margins. So let's type here 500, save it, and now the shadows work as intended. It's important to know that if we have shadow maps in our project and also we have many objects with WPO in our scene, they're gonna refresh the shadow map each time they move. So to optimize it, we can disable the WPO with the distance. To do this, click on our mesh in the scene, search for word position offset distance disable, and let's type here, for example, 1000. And now if I move my camera 1000 units away from the object, it's gonna disable the WPO. In this case, it's pretty obvious, but I guess not every WPO asset is a fan, and also this fan maybe is hidden in some pipe or something. But in this case, it's quite obvious. But the one thing you can see here is that even if we stopped our WPO, the normal map is still rotating. So we need to fix it. Here I created a little function that we're gonna use to disable our time from the rotate about axis node. So basically, it's gonna recreate the behavior of the word position offset disable distance. So we're gonna have a distance parameter. We're gonna multiply it by itself to make it squared. Here I have camera position subtract by object position, and then dot product of itself is gonna give me the distance between those two objects, but the distance will be squared. That's why I'm also doing the same with the distance value. And I'm using the squared, I'm using that one instead of the length, because instead of length, because the length is basically the same but not squared. And I'm using that one because it's just cheaper to calculate. The length is using square root, is one of the most expensive calculation for our computer to do. So that's just another optimization. And then I'm dividing that one by our object distance, which gonna give us value 0 to 1 from the object to our object position. Then I'm flooring it. So floor is gonna mean as long as it is not 1, it's gonna be 0, and when it passes the 1, it's gonna be 1. And when it's gonna pass 2, it will be 2, and we want to clamp it to 0 to 1, so then I'm using saturate. And now we can multiply our time by it, and apply. So after 1000 units, it's just gonna disable our time, and it will no longer rotate our normals. So here I am close to the object, it's rotating both normals and the geometry, and after 1000 units it's disabling the normals, it's disabling the geometry, and everything is now optimized. So the shadows doesn't need to be recalculated anymore. Now you can ask why to use material rotation instead of blueprint rotation with the rotating movement component. And the answer is it depends. If you need collisions to be updated, you should use the blueprint version, because the player can interact with rotating collisions. It's very important to know that in the shader variants, the collisions never moved. It's always static as the non-rotating object. So if you have any gameplay reason to rotate something, use the blueprint one. But if you want to use like 100 objects, it's gonna be much cheaper to use the shader rotation for many objects than the CPU-based rotation on the blueprint. So GPU is mostly for visuals and it's cheap, and the blueprint one is for the gameplay reason and it's a little heavier. So in case we know that player will never be able to collide with our object because maybe it's very small or maybe it's out of reach. We can also remove collisions from the object. So go to our object settings and just remove collisions if we don't need them. Yeah, and that's all for this video. I hope you like it and see you next time.